Well, welcome everyone to I was going to say the evening, afternoon session of .NET Conf Day 2, but this is going to be time zone relative, right? Some people it's evening. For us, it's like kind of mid-afternoon. We're here in Australia. But whatever the time is, thank you for joining us. As Justin said, we are going to be talking about Python and .NET and how we can use them together. My name's Aaron, and I'm joined with my colleague Anthony. Anthony, why don't you introduce yourself?
Hey everybody, I'm really happy to be here at .NET Conf. Something of an imposter as the Python person at the .NET conference, but that will come to become clear over the next 30 minutes as we explain why. I lead Python advocacy at Microsoft, and I'm a fellow of the Python Software Foundation as well, and a terrible .NET developer, as Aaron reminds me continually as we've been working together. So I'm learning, but yeah, great to be here.
Well, without further ado, let's talk about what we're covering today. So I'm a .NET developer. I've been doing .NET for the better part of the last 20 years. And as Anthony said, he's a Python developer. But with the kind of rise of like AI, machine learning, and data science, well, that leans very much into the Python space, right? Doesn't it, Anthony?
Yeah, absolutely. Yeah, there's a huge amount of libraries for Python that have been built to do machine learning, data science, pretty much every sort of underlying technology behind the AI models these days was written in Python.
Yeah. And from a .NET perspective, we can create APIs and web servers and all that kind of stuff really easily. We've got the value of things like type safety and stuff like that in .NET. That makes it a really compelling server option. But if we want to leverage these kind of libraries that have been built for data science workloads or AI workloads or anything like that in Python, well, it's really difficult to tackle that with inside of .NET just because, well, there's no kind of good analogy. And you don't want to reinvent the wheel every time. Or if you've got a team to say doing your data science at your company, you don't want them to have to become .NET developers because they're probably more familiar with Python. So, what have we built? Well, Anthony and I have been working on a project that we've called Sea Snakes. So, I'm sure people who kind of get the joke of the name. So what's the basic idea behind Sea Snakes, Anthony?
So the idea is that Python itself can be embedded into other runtimes. It doesn't need to be called from the command line. And what we wanted to do was to build a bridge between the power and the libraries in Python and the scale and the performance of .NET. So what we wanted to do is say, okay, you can take a package, a library from Python, you can import it into a .NET project, you can call it, you can send data backwards and forwards, and you can embed that in what you're trying to build.
So we've got a lovely simple flow diagram that kind of explains all that. But basically, we got some Python. I did this slide, so they're called Python methods, and as Anthony loves to correct me, is that no, they're functions in Python. But I'm a .NET developer. Things are methods, not functions. Functions are like Lambda expressions. We take those that are annotated with Python types, and then we generate C# wrapping code for that, so that we have this kind of interop layer between C# and Python, and then make that available within inside of a .NET environment because we now have .NET code. We're like, but we're not just calling Python.exe under the hood, as you said, Anthony, are we?
No, we're not. So I think earlier on, there's lots of other approaches for doing this already. You could take Python, you can put an API on top of Python, like a REST API, and call it over HTTP. But if you're trying to embed it in something like an ASP.NET Core API, then you've got your API and then you've put another API under that API, and you've kind of created this huge overhead between your actual initial API endpoint and the actual code you want to run. And if it's just a simple function where you're just giving it a few parameters, running some code in Python and running it back, it's really overkill to run that entire thing through a HTTP pipeline. So what we're doing is basically embedding Python into .NET so you can call the functions directly, or the methods. Let's call them methods.
it's a .NET audience here. We can call them methods because we understand what those are.
Good stuff.
All right. Well, I suppose without further ado, shall we jump over to a demo and have a look at how C-Stakes works? Do you want to share your screen, Anthony? And let's play the role of you're the Python developer because, well, I mean, you are. And let's build something in Python that I might then want in .NET. So, we'll jump over to Anthony's screen and have a look at that.
All right. Got that up now. Okay, so Aaron and I were talking about a good way of demonstrating what C-Snakes can do. And everyone loves a weather demo, so we're going to do a weather demo. And in Python, the way I would do a weather demo is I would start off by trying to get my data. And there's tons of ways of doing that. There's a really cool library that I like. You can basically just give it a set of coordinates for anywhere in the world, meteostat's called, and you can say until today, and it will go and fetch the weather for you and give it back to you for free. So I wanted to use that library. Also, I don't memorize GPS coordinates for cities, so I just turned this into a really simple little app where I could give it the location as like a string, like Seattle, USA, Sydney, Australia, for example. So I can run this app as a program, and I can do Seattle, USA, and then write that to a CSV file. So it's going to go and talk to that endpoint, fetch the data, and then I'm going to do a bit more manipulation as well. So it gives me the precipitation, the amount of rain, temperature, minimum, maximum, wind, stuff like that. But I wanted to characterize the weather for that day. So I said, if there was any snow, then make it a snowy day. If there was more than 10 millimeters of rain, let's say it's a rainy day, anything between 0 and 10 can be drizzle, and then anything else can be sun. So that's kind of my really simple algorithm that I've done using a couple of different libraries. One is called Meteostat, the other one's called Pandas. But this is really typical kind of Python work, which is taking data, working with it, manipulating it, and then spitting it out into a different format. So I've kind of got my app here where I'm writing it to a CSV file for now, because I initially thought, okay, maybe I could give Aaron the CSV, and then in .NET you could read the CSV, but then how would you call the Python code? And kind of the more I looked at it, I thought, okay, I'm also working in a Jupyter notebook. This is super popular Python. So I've got, I'm importing pandas. I'm reading that CSV file I just created. I'm looking at the weather data. I'm going to look at the last week to see what were the temperatures and what was the wind like, what was the weather like in Seattle in this case, and then draw that as a graph so I can see what were the temperature ranges in the last 7 days for that particular city. And then what was the rain like? So we've kind of got these two bits of code. One is this bit of this app here, which creates actually that app, which you give it a city and it will go and fetch the weather data for the last 8 years. And then populate that somewhere. I'm just dumping it into CSV for now, but it'd be good to do that into a database at least so that we've got something persistent. And I've got this other app, which is a Jupyter notebook, which spits out a graph. It's not a particularly pretty one, but we can work on that if we need to. That's not a problem at all. And then to make things a bit more complicated, in Python, you need to specify your requirements. So you'd say which packages your code needs to work. And that I'm using Pandas, Meteostat, and GeoPy to do the geolocation of the city. So yeah, that's what I need, Aaron. I need you to take my Python code and then make that into an API. So let's see what we can do.
Yeah. Well, okay. So let's jump over to my screen now. Because just before we jumped on this session, Anthony did send me the code so that I could get it set up. Because and as we talked about earlier, there's a lot of ways you could solve this. You could just do your own fast API or something like that. That's going to run that Python code. But then I've got an ASP.NET application that already exists, so I'm going to have my ASP.NET app. that is then showing that code. It's then like doing maybe a proxy pass through or something like that. So it all becomes a little bit more cumbersome when we're trying to use that within inside of the .NET environment. But if I was wanting to use C stakes, well, we can really simplify that. So in Visual Studio, we'll jump over to my screen in just a moment. See if that where's Justin gone? Oh no, he didn't give me the power to share my own screen. That's all good.
Oops.
Just making sure Justin is he's still paying attention. He said he was excited for this session. And so here's that app that Anthony was working on. Like I said, he said it to me earlier in the day, and I've got a .NET Aspire application that I want to use this in. And it's got a ASP.NET API that we're going to run, and it's got a Postgres database because we, like Anthony said, it's great that we can generate a CSV, but I want to kind of persist this data between restarts. So, well, like a Postgres database is a good way to do that. And it's also a fairly popular database in both the .NET and Python ecosystems. So I've got this file that I've added to my Visual Studio project called weather.py. I've got the weather forecasts function, which is going to give us a prediction. So that was what was being dumped out as a CSV before, but let's get from that data in our database. Well, let's just write that out as data that I could render in, say, a Blazor application. You'll see here it's using a cursor which is creating from a Postgres database connection. It's going to execute a query against that database, and then it's going to use that. This is using pandas as well to create a data frame, insert all of the data into that, and then create some data structures that will return. We've got that charting function that Anthony built out. So again, it's going to go to the database, it's going to select some weather data, and then it's going to plot that data frame into a graph that we can then return using, this is actually using a buffer from Python. And then lastly, we took that function that was generating the CSV, that kind of say like storage of data, and now it's going to seed that into our database. So it'll still go out and get all that data, do the manipulations to give those kind of classifications of what the weather was for the day. But this time, instead of dumping it CSV, it's going to write it into the Postgres database. So we've got all that ready to go. And we've done things like put type annotations in Python. So weather forecast, we're going to need to be able to provide it with a number of days. And then it's going to return us back a list of dictionaries, which is just string and like in any object. So that it could be an int, it could be a string, float, etc. And let's see how we can then use that in .NET. Well, like I said, we've already got some of this stuff set up, and we've set this up with C stakes already installed, and we have our dependencies under packages. We have our C stakes runtime. So that means that I can start using this inside of my program. I'm going to copy and paste in some code to save you watching me do massive amounts of live coding. And I did a live coding session earlier today, and it didn't go as well as I would have liked. So I'm saving you from the dramas of that. We're going to say what version of Python do we want to run. I'm running on Windows, so I'm saying that on Windows we're going to use the Python 3.12.4 version. But then because this is .NET that we're running, it can be cross-platform. We've just got some handling in there for if we're running on Mac OS or Linux. So we're going to look for a Python version environment variable or hard code to just the 3.12 with no patch release. And then we're going to use a builder pattern to inject some services into our DI container. So I'm going to say that I want with Python, we're going to say from NuGet, because Python is actually the Python redistributable package is available on NuGet for Windows. So I'm going to use that if it's on Windows. Otherwise, we'll look for the Mac OS installer, or maybe we'll just try and pull it from an environment variable. So they're like just kind of a couple of layers of where we can try and find Python depending on what's available to us. We're going to specify a location where our Python code exists, so that weather.py file. Because Anthony has a couple of packages that he's using from pip, which is kind of analogous to NuGet in the Python world. We want to bring in pandas and things like that. We're going to get it to install those packages using pip. And we're going to set up a virtual environment. So again, this is something that's fairly common with Python development. So a virtual environment where all those packages get installed into and that like isolated version of the runtime. So that is then going to give us a IPython environment in our DI container. Now, like I said, I've already got CSnakes installed, and because I've already got the Python file in here, when I've compiled, it's generated me a weather extension method for our Python environment. If we jump into here, this is our interop code that we get between the Python code that was written in Python and our C# interface into that. So we see it's kind of, well, this is why we generate the code for you. You kind of don't want to be writing some of this stuff out. But we've got our weather class, which is just an internal implementation of an interface. And then if we come down a little bit further, we'll see that there is this get weather forecast method, which, as we remember, was the name of our method here. Now, we've taken the casing. So Python, it tends to use underscores to separate rather than what we do in .NET, which is, where's my generated code gone? There it is, where we capitalize on the word breaks. Also see that it's detected that we had some typed arguments. So the int is turned into a long. It's more analogous from a Python perspective of the way that it handles ints. It also even picked up the default value of 7 that we wanted to assign. And then this is returning a read-only list because we said that we wanted a list back. And then it's a read-only dictionary because it's a list of dictionaries with string keys and a Py object, which is our own custom representation of it. Because we said it was an any, we don't know what it could be. So we might resolve that as different types later on. And then we have our other methods such as the weather chart and our seed database, which has a default string in here. And that's going to be a void because it doesn't return anything. So now these are just .NET methods that we could use in, say, well, let's see the database when our application starts. So I've actually got this database available here, and we're using Entity Framework in .NET. So we scaffold that up. We do a database migrate to make sure that all the tables are there. But then we can seed our database. So I'm going to access our weather API that we got back, so that interface. And then from there, we'll see that we have a seed database method, like we expect, because that's what we had inside of our Python code. Or the next thing we would probably want to do is expose some of that with inside of an API call. So I could throw in an API for getting the weather forecasts. So this time we're going to inject our iWeather from our service collection. And we do weather, get forecasts. Now I am providing a default value there, but sorry, a value there of 7. I can put in, say, 10 if I wanted 10 days. And then because this is a .NET Aspire application, we wanted to show how you can do that tracing from like all the way through the dashboard. We'll see that when we run the demo in a moment. And for that, we're going to pass through some trace information. What's the current activity that we're working with in the current span, so we can get all that linked. This is going to return back that read-only list of read-only dictionary, which we can then use link statements against to then turn that into a .NET strongly typed object, so this weather record, and then we're going to convert those to, say, strings, or we're going to parse that as a date time, or we can even turn those into doubles or floats or whatever values we want using the extension methods that we have in CSnake. So and then we give it a type argument that we want to convert that from the Py object into a particular type. Lastly, we have that chart, and we might want to render that chart to our UI as well. So in this case, we're seeing an extension method there. So we've got our get weather chart. And this time, we're actually getting back an IPy buffer because this is it's a buffer in Python, which is more analogous to kind of like a memory access that we might want to do. So we provide this as a Py buffer that you can then choose what you want. In this case, we want it as a read-only span of bytes. So that's going to give us access to those memory, the actual points in memory, which means that we never had to do any kind of like serialization or deserialization, which makes this super fast. Like this is literally going to be using the same memory that the Python code had access to. It's also dangerous because like we're doing memory sharing between Python and .NET. This is all running in the same runtime, right? Yeah, only potentially dangerous there. Anyway, let's run the application and make sure I copy and pasted everything correctly. Fingers crossed. All right, so like I said, this is a .NET Aspire application, so this will fire up in a moment. And we'll see in the Aspire dashboard, we won't have any kind of references to Python. Oops. If I bring this into screen, where is it? Here it is. Boom. There we go. Let's zoom that one in a touch. Okay, so we've got our Postgres database that's getting started up. We've got our PG admin backend. We've got our weather inside of that. We've got our API service. Now, this is, I put some health checks in there, so it's not ready yet. It is running, but it's still seeding the database, so it's in an unhealthy state because it's not finished to be done ready. And then the web front end is waiting for our API service to be up and running fully before it will then execute, then be available for running the application.
Do you want to drop into the console, Aaron, and we can see what's happening?
Yeah, we'll jump over to the API service console, and we can see here it's going through and it's doing like there's our pip install. So this is actually running pip, so it's doing package installations for Python behind the scenes, and we'll see. There we go. So that's now seeding the database from Python, and this message itself has actually come from Python. This wasn't a message that we put in .NET. We never had that code there, but if we come to weather.py, we'll see that we come down, where is our seed database method? And seed database from Python. So our Python code logged to the same logger that was used in our .NET application, which, like I think that's pretty nifty.
That's pretty cool.
All right, everything's up and running. Excellent. Let's open up our weather application. We'll come over to here and then drum roll. No, so we've got 10 records there, I reckon. That looks like about 10. And if we scroll down, look at that. There is a chart. That chart was rendered using a Python charting library. It's then been sent back as just a memory pointer, essentially, that we've then converted to a byte array, which we've sent down, that we've made available inside of our .NET application. And we can then see that, like I said, because we've provided all of that in .NET Aspire, I can see there is a call here to say the weather endpoint. And we'll see that there is our API service that's called the .NET API, and then it's called generate forecast, which was actually from the Python OTel. So this is actually running inside of that Python process. And even to the degree of, well, how did the Python code access the Postgres database? Well, because this is running in Aspire, we have this connection string, which is to the Postgres database that's managed by Aspire. That's there under the connection strings _ weather. That inside of our Python code, we're able to access that from the environment variables that Python had access to. Right? So this is all running inside of the one application context, which I think is pretty cool.
Yeah, so there's a question in the chat already. How is this different from IronPython? That's a good question. So this is embedding CPython, which is that's the Python that 99% of people use. And the reason we're doing that is because most packages and libraries for Python are really only compatible with CPython. So like NumPy pandas, all of those packages require special APIs and stuff, which are only available in CPython. IronPython is more like it's a Python interpreter written in .NET. What we're doing is actually the other way around, which is we're taking Python itself and embedding it into .NET directly. So, and then there's basically some clever parsing and code and stuff generation on top of that. So the stuff that Aaron was showing was how you drop a Python file in the project, and then CSnakes, the parser, will basically scan that file, figure out what Python functions you define, what they're called, what the arguments are, what the response types are, and then it generates all that boilerplate code. So it's very similar to the interrupt types in .NET for C, C++ nowadays. So if you do a library import in .NET and you give it a target, it will go and generate all the interrupt code behind the scenes. This is basically the same kind of thing, but for Python.
Exactly. And other things that we can do. I was just going to see if my Copilot is Copilot doesn't want to complete code for me, but we've done things like hot reload. So if you were to change the Python code, I suppose I could just go like logger.info hot reload.
Change the name of change the title of the graph, maybe that might work.
Oh, I could have done that. That was probably a better example. Where is our graph method down here, and then the title of that title, and then let's put let's just put a couple of exclamation marks. So what's happening behind the scenes is that the compiler will have detected all of those changes, and then we've got our hot reload with inside of our application. That if we jump back to the browser, and this is something I should have tested before, but look at that. Change Python code. We added those exclamation marks, and we didn't have to restart our application for this, because that Python code is just being reinterpreted and re-executed on the fly. And to Anthony's point before, compared to some Python where it is it's an implementation of Python, this is using the most common implementation of Python to just run your Python code.
Yeah, and then on top of that, like things that Aaron just showed, we've built specific integrations into the .NET tooling. So if something crashes in Python, you get an exception thrown in Python. Then in .NET, you'll see that exception. You'll see the stack trace from Python. You can inspect the Python frames. You can look at the variables from Python, but you do that within the .NET experience. So you don't have to like run two things side by side. And then we also worked on the hot reload feature. So if you modify any of your Python sources, then it activates hot reloads and reloads the Python module in the CSNX integration. So yeah, we've done all of that for you. And then the other thing I would have loved to have demoed, but we didn't have time, was Aaron showed how you can do a buffer, which is an extremely fast way of sharing data backwards and forwards between Python and .NET. You're literally just sharing the same bit of memory between the two in a safe way. But we support a single dimensional buffer, like a span. We do the 2D span methods from the community NuGet package. And if you need more than 2 dimensions, so if you're working with NumPy and you've got n dimensions, we also support the new .NET 9 tensor span type. So you can cast a buffer in Python, so you can actually create a ND array in NumPy, which is a really common way of doing machine learning. If you're working with training sets and stuff like that, and you get an n-dimensional array in NumPy, you can send that back to .NET as a tensor span and work with it directly in .NET.
Yeah. Well, we're just about out of time. So what do you want to do next? If you want to learn more about this, check us out on GitHub at aka.ms/cstakes/code. You'll also find the docs, and the demo application that we've just gone through today is up there. We're definitely looking for feedback on use cases for this, ways that you can build applications and all that kind of stuff, because this is something that we think is really valuable if you're building applications today and you want to leverage that stuff that we just don't have native support within .NET that is better suited in a Python workload.
Absolutely. So yeah, check it out. Let us know what you think. Let us know what you build as well, because we're really excited to see some of the cool experiments, and have a look at the Python package ecosystem, because there's thousands of really interesting packages out there. If you're interested in astronomy, if you're interested in pretty much any field of science, there's a big package out there with some really interesting and cool integrations. So it'd be great to see people build things with that and bring it into .NET and make really cool apps. So if you do that, let us know, and we'd love to see it working.
Cool. Well, Thanks for joining us today, everyone.